You may have seen we've released a new rack extension instrument called Parsec. Today, I want to give you a tutorial on all the cool stuff it can do. Now, I don't quite have the same technology to do all the 3D graphics and animation stuff from our last video, but if you bear with me, I think I just might have it covered. On second thought, I think I'll just stick to what I know. To understand the advanced sounds Parsec makes, we're actually going to start with Reason's most basic synthesizer, the subtractor. You've probably heard this sawtooth oscillator sound a million times before, but have you ever looked at it to see what it's really made of? To do that, let's open the Spectrum EQ in Reason to visualize our sound. You see those peaks in the frequency spectrum? Each peak that you see represents a harmonic frequency present in the musical pitch you're hearing. These frequencies occur in something called the overtone series, and every musical instrument follows it in some way or another. The sawtooth oscillator on a subtractive synthesizer sounds the way it does because it generates every frequency in the overtone series, whereas a square wave sounds more hollow because it only generates every other frequency in the overtone series. In subtractive synthesis, we sculpt or subtract from these frequencies to get our final sound. For example, if I turn down the low-pass filter, our sound gets more dull sounding as I filter the higher frequencies out of the signal. If I change the oscillator type to a sine wave, we can see just the fundamental frequency in the overtone series. This sine wave represents the building block of additive synthesis. In additive synthesis, sine waves, called partials, are generated one by one and added together to make a complex waveform. Allow me to demonstrate. If I take our basic sine wave here and add another subtractor with its pitch set to the next frequency in the overtone series, and another subtractor set to the third pitch, and another, and another, and another, and so on, we're starting to hear and see that classic sawtooth wave. The problem is, we've only created the first 16 frequencies in the overtone series, and it required a bunch of synths hooked up to multiple mixers and careful transposing of synth pitches and volume levels to create the right sound. Imagine if we wanted to create 500 partials, or 1,000 even. Obviously, doing additive synthesis by hand isn't very efficient. So instead, we have Parsec. Parsec brings the musicality back into additive synthesis. Now that we understand the basics of additive synthesis, let's take a look at how Parsec simplifies this massively complex process into something we can get our heads around, and even get inspired by. I'll create a Parsec instrument and reset it to the initialized patch. Parsec has many sections, like sound generators, filter and partial modifiers, LFO modulators, envelopes, effects, and an advanced modulation bus. But its initial setup doesn't actually use many of these sections at all. In fact, the initialized Parsec patch looks something more like this. And it sounds like this. Recognize that? It's our old friend the sawtooth wave. Instead of swamping us with 1,000 knobs to figure out our own harmonic series, Parsec's sound generators include predefined clusters of partials in some useful and musical presets. It's these combinations of frequency clusters that form the building blocks of your additive synth sounds. So, the default generator is the sawtooth cluster, and it looks and sounds very similar to Subtractor's sawtooth, even though we know that it's created in Parsec by hundreds of individual sine waves. We can do the usual stuff you'd expect on a synth, like adjust the pitch's octave, transpose semitones or cents, and even roll off frequencies by adjusting the slope and cutoff frequency of the sound generator's own filter, like this. So far, you might be saying, why aren't we just doing this with Subtractor? The answer is this. That level of control is pretty much where Subtractor ends, but it's where Parsec is just beginning. Parsec has two sound generators that look and function the same. Each sound generator has two modifiers in it. A modifier is pretty much what its name suggests. It modifies the sound in some way. Some modifiers act like analog filters you're already used to, and other modifiers get freaky on those partial clusters to do some otherworldly things. Each modifier type has two parameters that can be adjusted by the X and Y knobs. Let's choose a simple low-pass filter modifier and you'll see familiar controls on X and Y, cutoff frequency and resonance. And if we adjust them, the sound is exactly like you'd imagine. But since additive synthesis deals with individual frequency partials, we can do much more than this basic subtractive sculpting. Let's change the modifier to a brick wall bandpass filter. Set the width on the Y knob to the most narrow value, and sweep the X knob to control the filter starting frequency. You can actually hear the overtone series partial by partial as Parsek's brick wall bandpass modifier isolates all but one partial at a time. As you can hear though, the coolest stuff is happening when I move the modifier knob. So what would be ideal is if we had a way to control the modifier knobs without having to move them by hand. Well, fortunately, we do, and it's called the modulation bus. The modulation bus lets us assign the LFOs, the envelopes, or even external sources like CV input to control many of the knobs on Parsek's front panel. Let's route LFO1 to the X knob of the first modifier of Sound Engine A. That's really just a long way of saying the same knob we've just been tweaking by hand. When I hold a note and turn up the modulation amount, those partials start sweeping automatically. The amount knob in the modulation bus controls the width of the sweep, and the rate on the LFO controls the speed of the sweep. As with other LFOs you might be used to on a subtractive synth, we can change the LFO waveform for different results. A random waveform gives us some kind of sci-fi computer effect. Instead of the LFO, let's use the envelope section of the modulation bus. I'll turn the LFO1 routing off and instead assign the same modifier knob to envelope 1. Now, the knob sweeps based on the envelope's attack, decay, sustain, and release settings. Let's broaden the width of the sweep to more than just one harmonic partial using the Y knob's bandwidth parameter. And let's adjust our main amp envelope so that there's no decay, maximum sustain, and a longer release time. To fill out this sound, I'll turn on Sound Generator B, set its generator to string, move it down an octave below generator A, and I'll use the parametric EQ modifier to boost the high mids a bit. Here's generator B on its own. And if I use the balance knob, I can find a nice blend of both sounds. It's a nice moody sound, so let's make it even more moody. Let's crank the stereo spread and turn on the reverb section. Yeah. Let's record that. There's so much more we could explore. We could look at each modifier one by one, each sound generator type, different combinations of using the modulation bus, or ways to emulate classic analog sounds and even acoustic instruments. But this is a micro tutorial after all. So let's build out this idea entirely using presets from Parsek's factory sound bank. Let's add some percussion, kick, snare, a bass line, an arpeggiator, and we'll kick off the sequence with a sound effect giving us what's known in modern production as a fall. Now that you understand how Parsek works, the presets that come with Parsek are a great way to learn even more. Just load a preset and see which generators, modifiers, and modulators make it tick. You can also use the presets as a starting point for your own sounds too. Experiment. Try things. Additive synthesis is about creating new sounds for your music that subtractive synthesis can't easily pull off at all. And Parsec takes all that complexity of partials and overtone clusters and brings it back to what really matters in the end: getting inspired.